Hello everyone, this is Nandhini, Assistant Professor, Department of Computer Science at Dr. SNS Rajalakshmi College of Arts and Science. So in this video, we are going to discuss about multiple camera infrared tracking in AR. So let's discuss the multiple camera infrared tracking, which is called as an MIR. So this tracking is a technique which is used to enhance tracking accuracy by employing several infrared cameras to monitor and locate objects or the user's position in the physical space. So this is the picture of multiple camera infrared tracking. So the camera setup, first we discuss the infrared camera setup. So the multiple infrared cameras are strategically placed around the tracking area, often in a room or on a device. So the device like a headset or controllers. So these cameras are tuned to detect infrared light, so which is invisible to the human eye but can be accurately captured by the cameras. The cameras are calibrated to understand their positions relative to each other, which is creating a new known reference coordinate system. And next one is infrared markers or emitters. So the objects or users that need to be tracked or equipped with infrared markers or emitters. So these can be passive, which means reflective IR light, or active, emitting their own IR light. The markers are typically placed on key points of the object or body, such as on a headset, controllers, or even on the user's joints. And next one is synchronized camera capture. The infrared camera simultaneously capture the position of the IR markers within their field of view, because the cameras are synchronized and they can capture the exact position of each marker at the same time, allowing for accurate 3D positioning. And next one is triangulation and 3D positioning. Use the data from multiple cameras. The system triangulates the position of each marker in 3D space. By calculating the angles and distance between the cameras and the markers, the system can determine the exact 3D coordinates of each marker relative to the environment. And next one is pose estimation. So the post estimation is nothing but this with multiple markers tracked. So the systems can determine the orientation, which is nothing but pose of the tracked object or users. For instance, if a VR headset is equipped with multiple IR markers, the system can accurately determine the headset's positions and orientations in space, allowing the AR system to render content from the correct perspective. And next one is real-time tracking and rendering. So as the user or object moves, the system continuously tracks the IR markers, which is updating their position and orientations in real time. The AR system then renders digital content in the correct location, ensuring it remains aligned with the real world environment or the user movements. So these are the steps of following how multiple camera infrared tracking works in AR. So this is the example for multiple camera red tracking. So first we have to imagine a high-end VR gaming setup where so these are the steps to work the multiple camera infrared tracking in AR. So first we have to fit the infrared cameras. So several IR cameras are placed around the room. And the second one, headset and controllers. So once we fit the IR cameras, then the VR headset and controllers are equipped with active IR emitters. And third step is tracking. So as the player moves around, the cameras track the IR emitters on the headset and controllers, allowing the systems to render the virtual world from the correct perspective and track the player's hand movements. And the last one is interactions. So the player can reach out to the interact with the virtual objects with appear exactly where expected due to the precise IR tracking. So these are the steps to follow the multiple camera infrared tracking process. And next one is assessment. So these are the reference. Thank you.